Hello guys, how are you doing? It's your boy Dave, partner, and we're going to be looking at building applications on the blockchain, Ethereum blockchain, using a programming language called Solidity. And this tutorial is for absolute beginners, so the only prerequisites you should have to participate in this tutorial is that you've coded JavaScript before. If you've written any code in JavaScript, then you should be able to understand this tutorial. So I'm not going to assume that you know anything at all. Alright, it's for absolute beginners. And I'm going to make the code we're going to write very short so that you just get a general idea of how it works, how Solidity works, and how everything is connected to everything else. Alright, so let's look at the roadmap first, or the entire view. If you're building an application for the blockchain, let's say a regular application will usually have a front end. Hope you can see this. So in the front end, you usually have something like a Bootstrap, Tailwind, Foundation UI, or Material Design. This is something that helps you to write your HTML and CSS. So this is where you have your HTML and CSS. Then you have a backend code, and this is usually a framework at the framework level, where you have something like Laravel. If you're working with PHP, Django, React Native, Ionic, Angular, and Flutter. But also, you could be writing your code with vanilla PHP or JavaScript. It doesn't matter, or Python. It doesn't really matter, alright, but this is where you have your back end in a regular app. But then, when it comes to the next thing you would have after your back end is usually the database, right? And this is where the you would have. But in blockchain development, okay, what you would have is Web3.js, okay, Web3.js. This is a tiny little library, okay. Now, this library, some people call it framework. But this library, what it does is, it helps you to connect to Solidity. Now, what is Solidity? Solidity is a programming language that is written for the Ethereum blockchain. So these Ethereum guys built a blockchain, and what is the blockchain? Blockchain is simply a database without the edit and delete methods, okay, or functionalities. In the regular database, like your MySQL, you have CRUD, create, read, edit, update. But when it comes to blockchains, it doesn't have the edit and the update. So any data you save there is there permanently. Alright, if you want to update it, you have to create a new record altogether. The old one is still there, then you have to create a new one. You can't edit it. And that's the whole idea of blockchain, alright? So they built this Ethereum blockchain, and they have to write a programming language that helps you communicate with it. In your regular NoSQL database, what it will be is the equivalent. Solidity is the equivalent of SQL, SQL. Your SQL language, that's the equivalent of Solidity in blockchain development. So basically, a language that helps you communicate, get, and insert information into your blockchain. All right. Now, there's also MetaMask, Ganache. These are MetaMask is basically usually a browser add-on or app on your phone that helps you connect to the blockchain. Now, it's like a gateway, like a sign-in interface, like a small website, okay? But it's usually an add-on on your browser. We're going to see it shortly. What it does is you can use it to connect to a blockchain. There are test blockchains. Remember that you can't edit anything you put into a blockchain. So if you are building a blockchain application, you need to do a lot of tests, because once it goes live, it can't change. So MetaMask helps you to connect to some test blockchains or server. In regular programming language, that would serve as the interface, PHP PHP MyAdmin helps you to connect to your MySQL database that you installed in your system. Okay, guys, so that's MetaMask. Ganache is also a database you can save, a blockchain simulator you can save on your phone, on your system. You can connect to your Solidity to it and test your applications. It generates dummy currency for you, or coins, or Ether for you, alright? And dummy accounts you can use to test your blockchain and make sure it's working well before you push to live. And then there are other alternatives, but that's basically what it is. And then you have the Ethereum blockchain. So inside Ganache, there's an Ethereum blockchain. Inside MetaMask, there's an Ethereum blockchain. And these are test blockchains. But MetaMask can connect it to the live Ethereum blockchain too. There's a live Ethereum blockchain, alright, that is in many people's computers. MetaMask can connect you to that. This is not an introductory class to blockchain. I would have explained better what blockchain is, but just look at it as a database that you can edit or delete in, alright? That is, you can update information you put there. Alright, so this tutorial will be centering on Solidity. Okay, so we're not going to touch any other thing. We're going to code some Solidity in this tutorial. And what are we going to build? We're trying to write a smart contract. What is a smart contract? Basically, a contract that is written in form of a code. Imagine that you join an organization, and there is an employment letter that is sent to you. That employment letter is a contract, and the employment letter says, we will be paying you this amount provided you work to us from 8 to 5 p.m. every Monday to Friday, and for the first 3 months, and so on. There is a lot of information on that employment letter, but it's a contract binding two of you. And who enforces the contract? The law. If any of you breaks it, you have to go to court. But in blockchain, you can write a short code, the same contract, and write it in a code that is just in a page. And that code is self-enforcing. Okay, that's an example of what we want to write now. You don't need the government to enforce it. It enforces itself. Okay. So what we want to do is, for instance, situations where a founder, alright, when founders sell their companies, okay, or when a company is acquired, let's say a startup founded by 4 people is acquired by a bigger company. Now, the bigger company will issue their shares, the shares of the bigger company, to the founders, those 4 founders, but on a condition. It's going to be vested. Vesting means that you can't withdraw your shares until after 4 years. You understand? So they want you to stay for 4 years during working on that platform. After that, then you can withdraw all the shares and get rich forever. Okay, so we want to write a contract that will enforce that. Alright, on the blockchain. So I hope you now get an idea of what we want to build and where the blockchain is. Now before we go ahead with that, I want to explain something interesting that I wish somebody explained to me when I was learning blockchain development. Okay, and you need to know that I'm making this video for newcomers and beginners. So some analogy I might draw on this video might not be perfect. Some explanations I will give might not be 100% perfect, but it's enough to make you understand in relation what the blockchain looks like, alright, in relation to your regular MySQL and NoSQL databases, okay? So, look at this, right? How you save your data in the database, like in PHP-MyAdmin, for instance, or MySQL. So once you save data, that data has an ID. There's an automatic ID generated for it, and then there's a value, alright? And then usually there's an ID, then there are multiple values, right? There's an ID, there's a value, there's an ID, there's a value. Fine. In the blockchain, this ID will be the person's address. So everything in the blockchain that is saved into the blockchain is saved at a certain address. So this is an address, usually a very long string. So when you want to send Bitcoin to me, I have a Bitcoin address. This is what I'll send to you. So this is my Ethereum address now, but it's a text address, okay? You can't send live Ethereum to this. So, but if you want to send Ethereum to me, I'll put my real Ethereum address in the comment section so that you guys can donate to it. But you just take this address and you transfer Ethereum from your own address to this. Okay, fine. Now, if we're trying to save information in the database, we have to save it alongside an address. So instead of the regular IDs you would see in a regular database, it will be an address versus a value. Address, value. So the address is the key. and then there's a value. Alright, so in this case the address here is the key and the value here is 20, so we can say 20 is saved against this address or whatever. Alright, so you get the idea. We're going to see it in a better way once we start coding, but just know that if you want to save information in a database, you need an address, and then you need the name, a value, a key value pair to it. Okay, so which I did not include here. They're supposed to be perfect key. Alright, so here is going to be something like amount. It's going to be years. It's going to be paid, or in any case it's going to be something like is paid, you know. So if I scroll up now, you have something like this. So the same address, for instance, can be used to save so many things. Look at this. Same address, I can use it to say years. Okay. So I have an ID, then I have a key, which is an amount, and then I have a value. So which means I don't need to enter this. Now we're going to see code shortly, but I just want you to see this chart first, or this sheet first. Okay, you see how it goes. On the blockchain, there's going to be an address that is long like this, and then there's going to be a key that you're saving it with, and the value you're saving. Now, if you're writing a code, you have to say what variable type this value is. So we're going to put something like in our code, we're going to put something like int. You see? So in Solidity, it's called your int 256 20. So that the blockchain will know that this is an integer. All right. Okay, so we're going to look at that shortly. So now I hope you get the idea now. Anything you want to save or retrieve in the database, you have to provide the address and then the key. Alright, then it will bring the value for you. Alright, if you want to save something, you provide an address, you provide a key, and you provide the value. That's it. So no matter how many things you want to save, you keep providing those three keys. Beautiful. Now let's write some code. Alright. If you arrived at this point and you've not subscribed to this channel, or if you're watching from anywhere and you've not followed us on Telegram, alright, you need to follow us on Telegram. Just go to Telegram, search for Dave, or just I'll put the link in the description section below, or in the very next video, alright, or in the video before this, depending on where you're watching from. Make sure you join us on Telegram. I have a special package and gift for you, alright, and also you'll be getting notifications on new tutorials. So to write Ethereum, I want to make it very simple, so we're going to use a browser editor. Instead of using something like VS Code or Sublime Text, Ethereum built something called Remix. So visit remix.ethereum.org. Okay, remix.ethereum.org. Leave this side. I'm already there. I just wanted to open it afresh so that you see what it looks like. Remix.ethereum.org. Okay, are we there? Alright, usually there will be a pop-up. Just close the pop-up, alright? It's not really important. And there are plugins here, but what you want to focus on is on this side. So let me drag this. Usually here, Ethereum creates, look at this. Ethereum creates, make sure that this is selected, okay? This is selected. Ethereum creates sample folders for you. The Remix creates sample folders for you. Alright, it's basically like a framework for you already, but we don't need any of that. Okay, even if you leave it there, there's no problem, but we don't need any of that. So I'm going to delete everything. Okay, since we don't really need it. It's like when you install Laravel or Django, and Django comes with so many files and folders, but you want to delete everything and write raw PHP. Okay, it's usually better.
It's 10 o'clock.
Yes, delete. So, sorry, I zoomed in too much. So, yeah, delete. And delete. So, did you notice that I did not log into this Remix? You don't need to log into Remix. for you to use it. So we deleted everything. So we're starting from a blank sheet. Beautiful. Alright, now before we even start, look at this. It says default workspaces. So if you look at this, you see that this Remix creates workspaces for you. So if you're working on a project, that's one workspace. You switch to another project, that's another workspace. So today we are writing a code on how to invest shares or payments to founders. Okay, that's just one workspace. So we can name it anything, or we can just click here to create a new workspace. So if you want to create a new workspace, that's where you click. So you click this plus sign, create a new workspace. If you want to edit, click here to edit. So this one says default workspaces. No, I want to call it founders investing or whatever, so I can remember it. So if you want to work on another project, just click on this plus sign, and then you can delete the entire workspace. Another thing we want to do is to create our first file. Okay, so I'm going to click here to create file. You can create folders with this, and then there's this GitHub, and then you can upload. Okay, so here I'll click here to create new file. I'll call it founder.sol. Founder.sol. Sol is Solidity. So all Solidity files must end with a .sol. Okay. Now another thing you should notice is that I started with F, capital F. So your Solidity files should be camel cased. Okay, and has to start with a capital letter. Alright. So if I wanted to call this founders destiny to be something like this, okay, rename to be founder destiny. Okay, founder destiny, like this. Okay, so it's just a convention, not that things will break. Alright, the reason why it's like this is, you know, in regular programming, it's a convention that your class names should start with capitals, and then your file name should also correspond to the class name, okay, with the same capitalization. Alright, so now we can start coding. First thing you do in Solidity as at this time is to specify the license. Can people copy your code? That's what it means. So you do /, alright, which is a comment. So we're going to add a comment that is called spdx, okay, xpdx dash capital letter silent license. It must be written this way, dash identifier colon, then you put the license. So if it's MIT, you write MIT. In this case, by default, it's usually GPL -3.0. Now remember, we deleted some files here when we started. In case you forget this particular line, you can always copy it from the files that is automatically created. So if I click create new workspace now, click OK, I'm creating a new workspace. If I click, look at the files automatically created. So if I click here now, for instance, you see that it's written here, you see? It's written for me. So in case you forget it, you can just copy it. So let's switch back to our original workspace, founders vesting. Go back, and then we'll click founder.sol. Now we've got the license agreement out. If you don't put a license agreement, so this Solidity will throw error. This Remix will throw error. So now we're going to write the version of Solidity. You must always tell Solidity the version. So we're going to write pragma Solidity. That's exactly how to do that. Alright, you write the version. Remember, we saw it also in the other one. So now, as at the time I'm teaching this in 2021, what you have is Solidity 8.0. okay, that's what we have, and above. Okay, so I'm just going to say this program can run, this is up arrow, on 0.8, not 8.0, right? 0.8 and above, that's what it means. Okay, so we'll put this. Now, code you wrote on any version of Solidity can always work as long as you're compiling it with that same version. Alright, I'll show you what I mean shortly. Okay, so if you are coming from the future to watch this video and some new versions of Solidity has come out, it doesn't make this tutorial outdated. Okay, just make sure that you specify the new version here. It will still work perfectly. Alright, the next thing we want to look at is the class. Okay, we'll call it contract. So remember, it's a smart contract. That's why we have contract, and we call it anything. So I could call this vesting or whatever. Okay. Traditionally, it's supposed to be the same name with this, but who cares? It doesn't stop anything from working. So this is how you write a contract. Now the thing is, at the end of the day, you need to know how to write comments in Solidity. There are two ways to write comments. The first one is this way with double slash, okay? But then when it's being compiled, your front end, remember we talked about Laravel, Web3.js and so on, they should be able to read the comment, okay? So there's another way to write with triple slash, and then you put an @ sign, then you specify who the comment is for or what the comment is for. So in this case, you can say that dev, this is a comment for the developer, okay? Or you can say notice, this is a comment for just anybody that is reading the code, okay? So here I can describe what this code is about. Okay, another one is when you put param, like if you are writing a comment on top of a function and you want to describe what each parameter is. So here I'm going to do notice and say a smart contract to manage vesting of founders' shares or whatever. Okay, so good. Right, so the next thing we're going to do is to look at this place. So we'll do contract. Okay, we've done contract, so we'll do struct. So when we are vesting shares or money, we have to take care of three values. Number one is the amount we want to pay each person after a certain duration. Then the duration itself, how long before this person can get that money. And finally, we want to know whether the person has paid or not to prevent somebody from withdrawing multiple times. Okay. So I want to save all these things inside a variable type called struct. If you're a programmer, you would know what struct is. You know, there's int, there is boolean, there's string and so on. But struct kind of allows you to merge different variables into one. Okay, more like just very similar to an object in JavaScript. So I'll say struct founder. And then, so when you're defining struct in Solidity, it's advised that you use a capital letter so that just convention, so that you'll be able to tell. So in Solidity, integers are known as uint. Okay, uint 256 or just uint. Okay, so this is okay too. It means uint 256. There are different uints in Solidity, but 256 is the one that denotes the regular integer that you know. Okay, so we're going to create another variable called maturity, and the third variable is a boolean, true or false, which is to know whether this person has been paid. So I'm going to put a comment just to show you how comments run if a founder has been paid or not. You see? So we've created a struct. Fine. Then the next thing we are going to create is mapping. So when you want to retrieve a value from the database from the blockchain, you use mapping. All right. So now let's do mapping, and it's done this way. It's not exactly the same mapping you know in JavaScript, so don't let it confuse you. Okay, but basically it says that if we provide an address, it should retrieve these values for the address for us, the values we saved in struct. Okay, we save this. We're saying that if we give you an address, go to that address and try to retrieve these other items for it. Remember the database I showed you earlier? So we're going to do public founders. So basically we are defining it as a variable. Okay, so every time we call these founders and provide an address to it, it's going to give us what? Everything here. That's what it means. Okay, another one is address itself. Address is a variable type in Solidity. Okay, public admin. So when an address is public, it means that it can be accessed from outside its scope. All right. Now, good. We're going to create a constructor. remember this is a class, constructor. Okay, a constructor is a special function in a class that runs every time you call that class. In reality, this our code, Solidity code, is going to be called by a front end like Web3.js that is installed inside something like Laravel or React or Vue.js. So there is Web3.js is a library that we'll have to use npm to install into Laravel or Vue.js, and that is what is going to be calling or communicating with this Solidity, this code we are writing. So all these variables we are declaring as public, it should be able to retrieve it. Okay. Now also, whatever we have in Constructor will be loaded once our Web3.js makes a call to founder. Alright. So here we're going to say admin. This admin we declared. We're going to set the value of admin, and we'll set it to something interesting that is called msg.sender. That is message.sender. So it turns out that in Solidity there are global variables that come with Solidity. There are a number of them. Okay. So you can find it in their documentation. So let me just show you. Whenever I teach people, one interesting thing I like to show people is where I learned something, so that if you ever run into problem, you'll be able to go there and sort it out. Now, if you're watching this video and you run into some special kind of error, check the comment section below. Somebody would have provided the answer, or you can just ask. I might be there to provide the answer. So if you do Solidity documentation, so it's a documentation that everybody that wants to become a blockchain developer needs to read. So Solidity, if you come here, you'll see docs.soliditylang.org. So as you can see, at the time I'm writing this, 8.10 is the highest version. Okay, by the time I'm taking it in the future, it could be 9 or 1 or 2, whatever, or 1 point something. So look at this. This whole thing is the documentation. It's good to read. Alright, there's an introductory part, and then interestingly, there is layout, source file, structure of contract types, you see, and then units and globally available variables, you see. So there are different units. You just go through them. Time units is in seconds, okay, and this is how you can denote time, 60 seconds, whatever. And then there are functions, and then specially globally available variables. So this is what I'm talking about. These variables, you can use it in your Solidity anytime you want. So here are them. Block hash shows what hash of a given block when block number is one of the 256 most recent blocks. Okay. Block base, blockchain ID, current chain ID, block.coinbase, current block miners address. See, block.difficulty. So these are for miners, but then look at gas left returns an integer of the remaining gas. msg.data, complete call data. msg.sender, this is what we just used. It's an address, sender of the message. Okay, so, and of course you can check the other ones. So, but this is what I wanted to point out. msg.sender. So now, whenever somebody connects to a blockchain, you have to connect through a certain address. The blockchain must have an address that you're using to connect. So when people log in to our app on Laravel, for instance, or on React or Flutter, it's going to prompt them, it's going to trigger a MetaMask. Okay, MetaMask will ask them to log in using a certain address. Once they log in, connect to this Solidity using their address. That address is automatically available in our code for msg.sender. In Laravel, it will be the equivalent of auth user, alright, auth user ID. In PHP, that will be session user ID, alright. So here, it's the same thing as msg.sender. Okay, so now we have loaded it. There are many things you can do in your constructor normally, but for this code, I'm trying to keep it simple, alright. I just know that constructor is where you load all the basic things you want. So we want to save the current person accessing this contract. We have saved their address in admin so that we can use it later on. So here we're going to create a function that people can use to add, or this person can use to add founders. Okay, so we're looking at add founder. All right, Remember that normally in JavaScript, this is how you write a function. But in Solidity, there are interesting things you have to put in the function. For instance, if a function can receive money, alright, you have to mark it as payable, so I'll go external payable. External means that it can be accessed from outside, okay, and of course inherited sort of by other contracts, sort of, okay. Otherwise, you just leave it as public. Now, we're going to pass some parameters here. In Solidity, you have to define the parameter type. So the first thing we are defining is if you want to add somebody to one of the people that can vest their shares, we have to know first of all address, the Ethereum address of the person. So I've defined the variable called _founder, and it has to be of type address. Okay. The other parameter we're adding is an integer that contains something interesting: time to maturity. Okay. Let me put this so you can see. Hope you can see now. Time to maturity. Now, it's a convention in Solidity that whenever you are defining a variable that will be used only inside that function, you start it with an underscore, so that it doesn't confuse other variables you have. Look at this. You see, I have other variables, right? So this founder doesn't confuse it. It can only be accessible from within this function, and that's it. So by convention means that you can break the rule and nothing will happen. But if somebody else is reading your rule, your code, and they see underscore, they already know that it's just a variable that will be used within the function. Now, in traditional JavaScript, you can do PHP. You can do if x is not equal to y, like this. You can do throw error. Console.log.error, something like this. Console.log.error. This is what you would traditionally do in JavaScript, but in Solidity, there is a very handy function for that. It's called require. So the first thing we want to make sure is to check whether the spender, the person about to add someone, is also the person that is connected to this, is the admin, alright? So this person should be, let's say, check if msg.sender is the admin. Remember this admin, so I'm going to delete this. Or let me comment it out so you can see it, right? So this is how you check if something is not true or if it's true. Because if this condition does not fulfill, Solidity will throw an error and stop execution. It will not execute past this. So this is also like it has a return statement here. You understand? Okay. This is what it looks like. So if this happens, but then there is also an optional third variable where you put the message, the cause of the error. So you can say only admin allowed. Now I have to say something here. In blockchain, every single code you write costs money. It will make the gas fee high, alright? When people want to perform an action, if your code is verbose, it will cost them more to perform that action. So anything you want to write, you have to write it with the minimum amount of words possible. Okay? Alright. So here, we'll check for another thing again. Require founders _ founder amount. Make sure that the amount is not 0. Now the thing is that somebody can initialize, communicate with the blockchain with an empty address. Okay, so let me complete this first. So founder already exists. Okay, cool. Now here we're trying to prevent people from adding the same person twice. Okay. So let me write it on top here. Same founder cannot be added twice. So instead of calling it founder, let me just say address. Same address cannot be added twice. Now look at this. What we have here is founders. Founders says mapping. Do you remember? Mapping. And it's saying, remember what I told you, it's saying that every time we provide a special address to this variable, we treat this variable like an array. Look at this. This variable, we treat it like an array. And we're saying every time we provide a value for a key for this array, it should go get us what? An amount. So this founders points to this founder, which has amount, maturity, and paid. So we're trying to retrieve the amount. Okay, so every time we put this and there is no amount, and the amount must be empty. That's what we're saying. Make sure that the amount is empty when we are adding a new address or a new founder. Okay, if it's not empty, that means the person has been added before and allocated a certain payment or fee. You understand? Well, that means we've added the person before and given them shares. So this line makes sure that somebody cannot be added twice. So once you provide an address, so this is a function. Let me remove this. This is a function that takes in an address, okay, a blockchain address of a certain founder, and then also takes in a how long they have to stay to be able to withdraw the funds we are going to allocate to them. All right. So this time to maturity, what does it look like? It's epoch time. It's called epoch time. Remember epoch? If you're a programmer, you already know that. That is how many seconds that have been counted since 1st January 1970. Okay, that's the beginning of time. You know what I'm saying? In software development, computers count time based on how many seconds that have passed before this time. Okay, so now it's in billions of seconds already. Okay, so if we want to add extra, according to what we saw in Solidity, we can just, if we want to add 15 days, we can just say 15 days times 24 hours times 60 minutes. That's how many seconds that we can add to the current epoch time. Alright, and we'll get 15 days in future. But this will be done from your Web3.js, not from here. Okay, just know, I just want to let you know that. Okay, if you don't understand, if you've never heard of epoch time, just go to Google, type what is epoch. Epoch. Okay, you just type it and shows you, right? Epoch time. Or Unix time, okay, whatever. Okay, so this is just a number, an integer number. Epoch time is what's the current epoch time? Okay, you see, it started in 1st January 1970. Okay, so it's an integer number that computer uses to know the current time. Okay, so if you just want to add extra days, you just add extra days in seconds. But Solidity also allows you to add whatever. You can just say something like whatever time equal to time plus let's say 15 days. You can do something like this. Just check the documentation in Solidity to understand what to do. Okay, so here we have just checked for two things. Number one, the person trying to add a new person must be the same address that's connected to this blockchain. Okay, and secondly, the address must not have any money in it already, because if it has, then it wouldn't make sense. All right. Then finally, we do the adding. Let us add to the blockchain. So how do we do that? We say founders at location founder. Okay, that location of the address. So we're saying these founders go to their database at this location. This is what you're going to save. You're going to save founder msg value. Okay, block. I'm going to explain it shortly. Timestamp. plus time to maturity. Okay, and false. Okay, good. Now look at this now. This is founder. It's making reference to this struct. So when you want to use a struct in Solidity, you use it as if it's a function. So you basically do founder, if you want to call it, var1, var2, and var3. This is variable 1, amount, maturity, and paid. Okay, that's how you use struct. So now with this struct we want to save into the database. We're saying this struct, the first variable should be message.value. Remember that there's message.sender, which is the address, and message.value is amount, right? And then we're also adding timestamp. So this is a global variable in Solidity that gives you the exact time, all right? That the exact epoch time, okay, at any point in time, all right? And then is it plus underscore time to maturity, whatever variable that is passed here as the future time, okay, 15 days, 30 days, 4 years, all right? Like I said, remember that this function will be called from your web3.js, okay? So when web3 is calling it, it's going to insert an address here and the number of days or years here, all right? And then this function will automatically process these things and then add it. So false means that it has not been paid. Remember that we say that this is boolean and it can be true or false if founder has been paid before, so that the same founder cannot come back with the same address and expect payment again, all right? So once founder is paid, we set this to save this as paid, okay? At the end, once we have arranged this in a struct, we'll save it at this location. The location is what? The address. You see? The address. Alright? Okay. So, let's go into the next one. Function. Withdraw. So, we want to withdraw. Okay. Like I said, there are many ways to write this, many more robust ways to write this, but in this tutorial, I'm just trying to keep it as simple, basic as necessary and possible. Okay, so here what you're seeing is that we're trying to write another function. Now I'm going to put comments. So here it's going to have 1, 2, 3 at notice. First, okay, let's say first function that runs once contract is called, or whatever you want to write. So this one is more important. So here I'm going to do 1, 2, 3 at notice. Okay, and then we call it add founder and future time, time for withdrawal. And withdrawal time, time to blockchain, okay, whatever. Then another thing is 1, 2, 3. We do at param underscore founder, okay, the Ethereum address of the specified of the founder to be added. Another one is 1, 2, 3. We do param underscore time to maturity. Maturity can say the time in seconds. Okay, the time in seconds. Okay, whatever. So this is basically how you add comments in Ethereum. All right. Then inside your function, you can then use something like this, like check if person performing the action is the same person connected to the blockchain via MetaMask. Via MetaMask or whatever way they connected, okay, so that somebody cannot hack it. Alright, are we good? So let's write a withdraw function. A withdraw function is external. It can be accessed by other contracts. Remember that you can go to the Solidity Solidity documentation and read up on these things. Okay, I don't just want to dwell so much on them. Now in Solidity you can also specify what the function will return. Okay, and the nature of the variable that the function will return. So this function will return true or false. If the person successfully withdrew the money, then it will return true. Okay, so here we're saying founder, remember that's the struct. Okay, storage founder, I'll explain shortly. Founders msg.sender. Okay, sender. Now in Solidity there are two types of storages. There's memory and then there is storage. Okay, so one thing about memory, look at this. This is integer, alright, and we're passing in a variable that has to be an integer. Assuming we want to pass in a variable that will be a string. So assuming we do string, let's say we want to pass in a string, maybe somebody's name, okay, and we can do first full name. So string consumes more gas fee in Ethereum than other types of variables, so you have to be extremely careful using strings. But if you ever have to use strings, according to Solidity, you have to specify which memory Solidity should save it. Is it in storage or in memory? So save it in memory. Now here's the difference between storage and memory. Storage is permanent. Memory will just run within the function, and then Solidity will clear it. So see it as RAM and ROM. Okay, RAM is temporary. If you restart your system, RAM is gone. Okay, if you close the application on your system, RAM is cleared. Okay, all the memory that the application occupied on your system will be cleared. Same thing with Solidity. Once this function has run its course and got to this point, the whatever variables that are saved here will be cleared. Alright? But also, if you want to change a variable that is a global variable, not global now, but state variable, okay? This founder is here. You see, it's outside even before the constructor. So if you want to alter any of the variables here, you have to use storage. Okay, so storage means that this thing is actually going to be saved on the blockchain. It's not just for processing any transaction or any function or anything, or performing any calculation. For instance, if it's in JavaScript, I can do var x or let x equal to y plus z. This is just a calculation. I don't need to save this on the database, right? If I'm working with JavaScript. But if I want to save with the database, I have to make a connection to the database, connect to the database, and then make the save. Alright? So in Solidity, you just need to define it as a storage. And then instantly Solidity knows that this is going to be saved on the blockchain. Okay? So basically we're saying, okay, we're going to save this on the blockchain, and what are we going to save? We're going to save the sender. Okay, here we're just trying to retrieve. Go to the blockchain, alright, get the sender, the person that is connecting to this code. We're trying to get their details, okay? We're trying to get this. Now we've retrieved their details. So this is how to retrieve from storage. So we say go to storage with this address that we're providing you, which is the address that somebody used to connect to this blockchain. Retrieve these details for this particular address, which is amount, maturity, and paid. We want to retrieve these three values. Interesting. So I will require founder.maturity. Now you know what require is. So can you guess what I'm trying to do? Log.timestamp. Too early. Okay. Can you guess what this line is trying to do? So this line is saying that once we've gone to the database and retrieved details for this particular founder and saved it on this variable, so we came here, retrieved those struct details, and we saved it here, we can access each of them by founder.maturity, founder.amount, that is founder.amount, founder.maturity, founder.paid, you see? So we're accessing maturity. So maturity is time, right? time in epoch. So we are saying get us the current time in epoch. Let's say today could be in epoch time, it should be 1 million whatever second. It will look like this. And we're saying get it and make sure that the maturity time is less than today, which means the date has passed. So for instance, if this is today, okay, yesterday will be something like the same number minus 24 hours, right? Yesterday is going to be the same number minus 24 hours. That's yesterday. 24 hours is 24 times the seconds. 24 times 60 minutes, right? Times 60 seconds. That will be how many seconds that will give you 1 day, right? So we're saying this particular today minus this number of seconds will give us yesterday. So as you can see, yesterday will have lesser number of seconds than today. That means yesterday has passed. So if you give me two dates, the one that is greater is the one ahead. Okay, so we're saying that for somebody to be able to withdraw, the time for their withdrawal must have passed, which means we have reached that date that they are supposed to withdraw, and at least we have passed it by at least 1 second. Okay, that's what this shows. Block timestamp must be greater than time to maturity. Okay. So if it is not up to that amount, that means the person is trying to withdraw too early. So we'll have to give the error. Sorry, you are trying to withdraw too early. Make sure the withdrawal date has passed. Okay. So we check another thing. In Solidity, you have to do a lot of checks. Okay, so we're doing founder.amount must be greater than 0. Okay, otherwise founder.amount must be greater than 0. That means there has to be money in the account for them to be able to withdraw, right? Remember that you mustn't put a warning. You must not put a warning. Okay, it's optional. Finally, we can say founder.paid. The person must not have been paid. Must be false. Okay, the person must not have been paid. If it is not false, then you give the error paid already. Okay, and then now we have done these 3 checks. The next thing we're supposed to do is to set the founder.paid equal to 2, because we want to pay this person now. Then we'll make the payment payable. This is how to make payments in Solidity. Pay this address. Which address? The current address that is logged in, because that's the person doing the withdrawals. Like when you put your ATM in an ATM machine. So we're saying pay this person the current account that is currently logged in. What amount? We are going to pay them the amount that we saved in the database for their account. So this founder here, this is where we initialize it, remember? So this founder is pointing to the address of the currently logged in person. We're saying go there in the database, retrieve the amount we're supposed to pay them, and actually effect the payment. That's what this line says. Alright? And this function, we can leave it without returning anything, but since we have said that it's going to return something, this is what I mean. We can leave this function this way. It's perfectly like this. Or we'll leave it this way. Public. You see? It's perfect. So, but since we want it to return something, the web3.js that will communicate, we want it to get a feedback to know whether the transaction went. So we can say return true. You see? Perfect. So this is how to make a payment and transaction in the blockchain. Now, the final thing I want to teach is here. Look at this. So we've been writing our code. Let me zoom out. How do we zoom out here? It's crazy. I'm not used to this browser. I'm using Opera browser. Now I can't figure out how to zoom out. Okay. Good. I've zoomed out. Now you can see we've written this code. It's time to check whether our code runs. Look at where we were before, and here we can click here. Here is where you can do your compilation. Now there's something interesting. you have to select the exact compiler version that matches what you specified your code to be. So here our code is 0.8 or above. This caret means or above, from 0.8 and above. So 0.8.7 can run this code, right? Fine. So we are running the Solidity. The language is Solidity, but you know there is U, right? But the language is Solidity, and EVM compiler, we're using the default. We're not touching that. And we can set auto compile. Like if you're writing a number of code, you don't need to always compile it. So once you set it on auto compile, it will compile, then it's going to show you errors. Okay. If you made a mistake in your code, this is where you're going to see it. So the mistake we use is say unused parameter function. Unused function parameter, remove or comment out the variable name to silence this one. Founder.so on line 29. So on line 29. Very good. It has spotted what I used as an example here. I use string memory full name as an example. So I'm going to, and we never used it, so let's connect that. Connect. Maturity. So if we go back, I've run into that problem again where I don't know how to minimize. So here we go. It has compiled. Look at this. So we don't have any errors again at all. You see? Interesting. So if you have compiled successfully, you will see this. This will be in green. Now we'll move to the next tab that says this. And the next tab, this is where you can deploy it to the Ethereum blockchain. Okay. In this case, this is just a test. Remix is helping us to deploy it to a text blockchain. And here, you'll see that it has generated sample account for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sample accounts. Okay, and it's asking us which of the EVMs should it use. If you're going to be writing a real life Solidity and you want to connect with Web3, you should use Web3 provider, right? Okay, or injected Web3. But here, I'm not using any of those things. So we're going to use JavaScript virtual machine. We'll leave it there. And this is our original address, okay? And then this is the gas limit. Gas is like every transaction that happens on the blockchain, except it's like a commission. The blockchain will take a commission. So that's what gas is in layman's terms. Okay. Now this is the contract we want to run. In case we have several files, several contracts we wrote, we can select from here. Now it's time to publish or deploy. So we click on deploy. So if you click on deploy, look at the lower part of your screen. Okay. So here, so it says, it gives you the message of what's happening. It's saying creation of vesting pending. Okay. It says here frame this particular address. Look at this address. Okay. So vesting, constructor value, whatever. So it has done everything. And if it wasn't successful, you can click on debug here and click on this arrow to see more information. Look at everything it did. It's here. Well, basically our smart contract ran well. So if we scroll down, now we can see here how to use it. So click this arrow. So a quick look at what we have here. We're saying that if the person connected is also the person connected. No. What we need to say is that if the person we're trying to add is also the person connected to the blockchain. Okay, so that's what I'm trying to say here. Now, of course, there are so many other things you can do here, or many other ways you can approach it. But second thing you want to do is make sure that you have compiled here. Make sure that it's green. If it's not green, I set mine to auto compile. So every time I change anything, it will recompile. Okay. So otherwise, you just click compile, and you're good. So if you come here, you can click deploy. Now look at the button here. Every time you deploy it, it generates a new address. That address is where the contract is deployed to. Okay? It's different from the address of the person connecting to the blockchain, two different addresses, okay? The address of the person connecting to the blockchain is like the account number, but the address of the contract is like the database ID where the contract is saved. Okay, two different addresses. Alright. So here we can click deploy. Every time you click deploy, the blockchain generates a new address and deploys to that new address. So if you click deploy 10 times, we'll have 10 addresses here. So let's look at it. If I click deploy, deployed successfully. And then here, what do we have? You see? Two addresses. So if you want to test what you deployed and you're not careful, you could be testing a previous deployment. So usually when I want to deploy, I'll use this here to cancel, to delete the old deployments. Or you can use this to delete everything once. So these are our old deployments are gone. If I click here, it's going to tell you that you have no contract instances, okay? Alright, so now we can redeploy. So every time you make a mistake in your code here and you want to fix it, after fixing it, make sure it's compiled and delete previous deployments or instances and then redeploy, okay? So we deploy again, boom. See, that's deployed, fine. So we can now come and check what we deployed and test our code. We click this arrow here and then you'll see that interestingly it has, let me bring this here. Solidity, interestingly, has our functions and also our variable declarations here. Look at this variable, this admin, this is it here. So if I want to see the value of this admin, I can click this. And it shows me the value. Look at this value. The value is 0x4. I don't know if you can see it. 0x4b20. Okay. Now compare it to the value of what we have here. The contract that deployed this address. Isn't it the same? Look at it. 0x4b2. You see? It's the same. Good. So if I want to copy this contract address, I'll copy it. Click copy. Now, according to our code, the contract that deployed this address must be the one that is adding a new address. Okay, remember that it's not a perfect code. You can write yours in any other way. So if I click here, come back to the deploy contract under add founder. Remember that our function, add founder function, our function can take two parameters, and that's you have founder and time to maturity. Okay, so we can put it the founder's address, comma, and the time to maturity. I'll use seconds. I'll just put 5 seconds or 3 seconds. So here under add founder, we paste what we copied. Remember, we copied this guy, copied. Okay, and then come here and paste. Control V, paste, then comma, 3 seconds, that's 3. Okay, and then I'll click add founder. Now I want you to focus on what's going to happen here in your console. So if I click add founder, it goes clean. Okay, it worked. So founder is added. Now let's look at reading and understand what was the information in the console. It's very important to be able to debug your Solidity code. So in the console here, what you have is debug. So if I click this debug or this arrow, it gives me way more information. So I can drag this up, right? And then I'll zoom in. It gives me very interesting information. Here it says status. True, transaction mined and execution succeeded. So there was no error in our code. Okay. From this is the address. Okay. This is the transaction hash. This address to what? This particular function that took an address and an integer. Okay. And was mined to this. Look at this. Compare this address. This particular address is not the same with the address that logged in and performed the transaction. So this is where the transaction is saved. Okay, a gas fee of 8,000 was collected. Is it 8,000 or 800 million or whatever? Transaction costs, okay, 50 gas. Execution cost 50974. The hash. Input, okay. Decoded input. Now the input is what you passed in, the parameters you passed in. So we passed in this address and we passed in this time to maturity is 3 seconds. Okay, so which means after 3 seconds, this person can withdraw. And then there are logs, nothing in the logs and nothing in the output. So this function did not have any output. Okay, so this function we had no output. Where is the function? So I know why I'm showing you this, because I want to try something else, so you'll learn more about Solidity. So this is the function of add founder. It has no output. Okay. All right. Now, what if you are building something? Usually, when you're writing code in something like JavaScript, you would need to use console.log to log events to your console so that you can see what is happening. All right. In Solidity, it is called event. Okay, so you declare and define the event, then you use it as emit. So you emit information to the event, all right, and then the event will print it on your console. It will be included in this output. Okay, so here's what I mean. So let's say here inside this function, all right, we have done this transaction, we have added this user, all right. Now we want to also log it so that we can see it in the console. The first thing we're going to do is define the event somewhere above the constructor, okay, where we did our mapping address, whatever. Just say event. Okay, so not capital letter but small letter event. We put a bracket, then we'll put it just like a function. We'll list any number of parameters we want to add. So what I want to print out in this case is 2 parameters, founder and time to maturity, and then a random string. Okay, so we're going to print an address that we're going to call founder events. Okay, we also need to print a uint 265 that we're going to call time to maturity event, whatever. Okay, remember you can use underscore. It's optional. So finally, we're going to print a message that's going to be string. Remember, I told you that you always have to specify memory whenever you want to use a string in as a parameter in a function, but you don't do that in an event. So we're just going to say string message event, whatever, event message. I'm just making up these names, then I'll put this. Now we've declared what our event. We need to give this event a name, and we're going to call it add founder event. You can call it anything. You can call it add founder anything or anything, whatever. So, but I'm going to call it add founder event so that I can tell it's an event. Okay. So here, after performing our function, we need to do console, the equivalent of console.log. Okay, the equivalent of console.log is we do emit. We emit that event, add founder event. Emit event. Okay. And then 3 parameters. The first parameter is the founder, so we'll just say print this founder for us. Whatever was passed in as the founder, underscore founder, underscore time to maturity, underscore the message. Remember how we declared this? We said founder, time to maturity, and then message. So whatever message, that's it. Okay. So having something like this will print to log. Okay. So it is good in the sense that if when a Web3.js is consuming this Solidity contract, this message will also be sent to the Web3.js. Okay, so you can read it in a JSON format. So with your code, you can read it from the you can read it in JSON format and print it to the user. All right, using HTML, CSS, or JavaScript or PHP. Okay. So now let's run this contract again and look for this event. All right. So it's a very, very good debugging tool. Very, very good debugging tool. Okay. So our contract is auto-compiled, which means there's no error. If there's an error, you will see it here. Okay. Now, before I forget, this is written in Solidity, right? But for your Web3.js to consume this code, it has to consume it in a specific format, in a JSON format called ABI. Look at it here, ABI. So if I want to get the ABI for this smart contract, I'll click on it. It will convert this code to JSON format and give it to me. It's called, is the opposite of, not the opposite, but the sister to API. API is Application Programming Interface. Okay, but this one is called application binary interface. Okay. Now, if you want to learn more about it, remember that I have more tutorials. Okay, and you need to follow us on Telegram. Okay, get to the link below or in the next video or the next slide. Get to our Telegram group and join, and that's where you can ask questions if you really have. Okay. So now here, it's auto-compiled and there's no error, which means our code is fine. And then we'll come here and right here. Then we can test our code. We need to deploy. So first off, I want to delete the previous deployment. Delete, so that it doesn't confuse us. And then make sure everything is fine. I'll click deploy. Everything deployed fine. So you see, the latest deployment works fine. Now we have to test our code. So if we look at the debug, I want to look at the debug section. Look at this. I want to click this. We zoom in. It just contains information about this current deployment. All right. So when we run any other thing, any function, it will give us information about the function. So keep an eye there. And here we are. Hold on. Okay, good. So right back to this, and remember that we deployed. I'm going to copy the address of the deployer because we said that's the only person that can add a founder. So we'll copy the address of this deployer, and then we'll come here, this arrow on this latest deployment. Click the arrow, and now it shows all the functions and everything here. So we'll paste the address of the deployer. Okay, paste. And then we'll put comma, the second variable, which is time to maturity, and we'll call that, I'll choose 3 seconds. I don't want to choose a large number. Otherwise, I've deleted what I put there. Hope you can see. So let me clear everything. If I paste the address of the deployer, okay, and I click this arrow, it shows me a drop down boxes of all the parameters I can put. Look at this one, time to maturity. So instead of using comma, I can use that drop down to fill in the boxes. So here I want to just enter in 2 boxes 4 seconds, and I'll click transact. So everything on the blockchain is a transaction. You see, it went successfully. But remember what I wanted to show you. I wanted to show you the power of emits, how to use events and emits. So look at this arrow now. If I click on it, so I'm zooming. So what you see is status usually from, this is the deployer. I'm calling it deployer in quotes, alright? So this is the deployer, and this is the function that just executed, okay? And this is the address of the execution, okay? Then these are the gas fees, and this is the input. The input was this address of the deployer and 4 seconds, okay? We did not put any output, okay, because there is no return statement. If there's a return statement, then you see an output, fine. Now, here is log. Log contains everything, but interestingly, look at this last. Look at here. It contains the address of the deployer, contains 4 seconds, and then contains whatever message. Alright, isn't this what we entered in the events? Look at this, compare the two. This emits add founder event. You see, the event is add founder event, and it contains what? The founder, time to maturity, 4 seconds, and then contains whatever message. You see. So in case you're working on your smart contract and you need to log things and see what is actually going on in your code, this is exactly how to do that. If you want to pass a message to whatever application that will consume this, fine. That's exactly how to do that too. Alright, so hope you see how to debug issues. I would have hidden the errors that I ran into, but the reason I did not hide it is because it's part of programming, and there's a rule of thumb. If I'm running a tutorial and I run into a problem, I don't hide it from the user, because the users might run into the same problem. So I just show them how I resolved it. Alright guys, there are many tiny little other things that about Web3 and Solidity, but this shows you a basic idea of the code. Now, the source code will be in the link. Get to our Telegram and pick it right? Okay, to be in the link, to pick it, and then gain access to other source codes. Another thing I want to do is to show you the full code in case you want to take a screenshot. This is what the full code looks like. Thank you very much, guys. Make sure you like, subscribe to this channel, alright, and share this video. Thank you very much. See you. Alright, guys, somehow I forgot that we needed to test this second function too. Okay, remember that, so I had to rewrite the code and make sure that I got it to where we were before we started. So this function is slightly different in operating.
It's 9 o'clock.
To Solidity. So Solidity treats functions that will involve a transaction. Solidity treats them differently. Okay, so this function now is going to involve a transaction. So make sure you have payable here. Payable. Alright. So this one doesn't involve a transaction. And let's go to this place. Now there's another error, but you are only going to see it only if I try. Okay, so given this now, look at the code and let's see if you had spotted the error. Now let us deploy this smart contract. Okay, I've run it and it's compiled already, and let us deploy it. Now for us to deploy it, let us look at this emit function. Look at this emit function. So if I copy this emit, I want to paste it somewhere here. Okay. We're going to run into some errors, but this emit is going to help us. I'm supposed to put it here though, but let me put it here first so you see what I'm talking about. So this emit will have, first of all, we want it to emit an address. So the founder address, so say message to sender, message to sender. So we want to see the address of the sender. And the second thing is an integer. So let's see the amount involved here. An integer should be amount. Okay, and let's change this message to withdrawal message, withdrawal event. Now the same thing here, instead of having whatever message, let us have, just for the sake of clarity, add founder event. Okay, beautiful. Now instead let's say message, add founder event message, withdrawal event message. Okay, so just so that we can see from the console what is happening. Now another thing is, since we've seen time to maturity, it works well, let's use this event to test something else. Amount. Look at this amount. This is supposed to contain the amount for the transaction. Did you notice that we didn't say much about it? So instead of the event showing us time, let us use the event to see if we can see what amount that was used in this transaction and the amount that is available here. Okay. Now in Solidity, global variable msg.sender has the address of the person that connected to the blockchain. Okay, but also msg.amount, msg.value contains the value, the amount of that transaction. Okay, so let us try to access it. Let's see what happens here. Alright, so far, let's deploy this contract, but this time we have to enter an ether value. Okay, you can also use GUI or way. So this msg.value, the msg.value contains the way. Okay, and remember that ether is 1 with 18 zeros. Okay, each of those 18 zeros is a way. Okay, alright, so msg.value, the denomination is in way. Alright, okay, so let's deploy this contract with, let's say, 5,000 way or whatever amount, and this way is supposed to be the amount that each founder will, this particular founder, let's say we're trying to add a founder, and this amount here is supposed to be this amount here. So this is the amount they will be able to withdraw after the time to maturity seconds. So we're deploying with 5,000 way. You can change this to Ether, whatever, but just remember that Remix gives you only 100 Ether. Okay. Alright, so we deploy. Make sure that our past deployments are not existent, so we don't have any deployment left. Okay, no deployment, so we deploy. Now, one thing you notice here is we have an error, so let's look at what the error says. Let's look at what the error says. It says reverts. Transaction has been reverted to the initial state. The called function should be payable if you send, let me do it, okay. The called function should be payable if you send value and the value you send should be less than your current balance. Okay. So what is our current balance? Our current balance is, according to this, 48 Ether. Okay. In your own case, it should be something like 99. All right. I can select any of them with 100 Ether. So this is like 48 Ether. Fine. And it's telling us that if we're going to make a payment, it says that the called function should be payable. Now, what's the call function? Whenever this class is loaded, the vesting class, the constructor is the first function that runs. So it's telling us that the constructor must be payable. Okay, if we are going to add any money to this transaction. Okay, so let's try again. So here we have 5. We're adding, let's say 50,000 way. I would like to put this in Ether so it's easy for you to understand. So in Ether, remember we have 48 Ether. Look at it here, 48 Ether. So we can just change this to, let's say we are giving 4 Ether to this founder. Click deploy, and now there's deploy. You see that it has run because what, the constructor is now payable. Okay, so if you are running this code in the future, just know that Solidity does improvements. So in case you get to this point and you see an error, it's probably because the version of Solidity that you have will have a different demand. So just read through it and be sure of what happened. And if you're confused, remember to Google it. Now, before we continue, what I want you to see here is let us look through the log. Let us take a look through the log and see. So I'll click on debug. I'll zoom in. Okay. So let's look at the emit. We want to see what is in the emit. Okay, we just deployed it and there is no problem. Let us try and do a transaction, which is let us add a founder. So I'm going to copy the address or hash, the address of this person that did the deployment, and I'm going to go to the contract, and under add founder, I'll just click this arrow and then I'll paste the address, and then the time to maturity, I'll give it 2 seconds so that we can test it, and I'll click transact, and boom, the transaction went well. So this is what I wanted to show you. So let's come to this debug, click on this arrow, and then we'll scroll. What you see here is that we're looking for the emit, add founder events. Okay, it has what, the first parameter is the address of the guy that did the deployment. Good. Second parameter is 0. Why is it 0 even though we added 4 Ether? You see, so our code is not complete. Look at add founder event message. You see, 0. So this amount, this variable does not give us any value, even though it's not picking the 4 Ether that we added. So how do we do that? Here, in the constructor, when this is loaded, this class is loaded the first time. Let me zoom out. Hold on, let me zoom out. Okay, good. So here, when this vesting is loaded the first time, we take the address of the sender, the person that loaded it, and we save it in a variable called admin. We need another variable. Okay, so let's start. This variable will save the value of the transaction. That is what we just the value we entered here, this value. All right, so we're going to say this value is going to be an integer, uint 256, that's it, and it's going to be public, and we're going to call it admin value or whatever, payment value, transaction value, whatever you want to call it. All right, so this is it. Now this transaction value, we're going to initialize it in the constructor and say constructor transaction value is equal to msg.value. Remember where I got this msg from, the value is one of the global variables. Okay, so now we've run this. Our compiler has automatically compiled. Remember that I set it to auto compile. Otherwise, just click this compile. That's done automatically. We'll come here. We'll redeploy. Before we redeploy, we'll cancel this. Okay, so we come here and we'll redeploy. We'll say, let's say we give this guy 6 Ether. Okay, and we click deploy. Everything went well. Okay, so now interestingly, we can then copy this address. Okay, it is copied. We'll come to the smart contract we deployed. Okay, I'll click this arrow, paste the address, and say 2 seconds, and say transact. We're trying to run this function. Okay, transact, and it went well. All right. Why did it go well? Because now this is payable. Now let's look at. Now we have access to this. We can then use it here in our event just to see it. So paste. Oops. Transaction value. We'll paste it here in our event. Paste. And then here, look at what we're doing here. We're saying call the founder struct. Okay. Call the founder struct here, and then the value of the transaction, that is the amount. So here is where we're going to put transaction value. Okay, and then this is timestamp and this is false. So remember that this is the amount. So that's how we save the amount, and I put it here so that we can see it in the logs. And let's try running this. Okay, so we delete the old contract. Come here, choose any amount, let's say 3 Ether. Click on deploy. It went well. So we copy the address and come here, and then click on this, paste, click this arrow, sorry, paste, then choose any number of seconds. I'll choose to click transact. See, it went well. And if we go to the logs, we'll see something interesting. Go to the logs, zoom in. So now you see interesting. We chose 3 Ether, right? That's 3 with 18 zeros. So it said add founder event. Add founder event told us that here, add founder event told us that the founder, okay, with this address, the transaction value is, you see, it's now available, 18 Ether. All right, 3 with 18 zeros. Okay, good. So now we have done that. Let us try the second function, the withdrawal function. Okay, withdrawal. Let's try and withdraw. So still the same contract that went well. So we'll click this. Still on the same contract. We'll click withdraw. Okay, click withdraw. So withdrawal went well. All right. So let us check the emit. This particular emit. Let's check it out. So it does this. We'll scroll down. Here you see that it logged the event properly. Withdrawal event message. See, we withdrew 3 Ether. Okay, so that's how to debug your code and make sure everything is working well. Like I said, in the future, if you ever run into problem, if your code is exactly like this and you run into any problem, it's most likely because the new version of Solidity you are using you are not using this version. The new version you're using has some new demands. Okay, so just take the error you see in your timeline and paste it on Google, and then you find the solution. Otherwise, make sure you use exactly 0.8 Solidity version. So for the last time, I just want to scroll through my code so that you can take screenshots and be sure that your code matches mine exactly. Okay, and otherwise, this code will be on GitHub. You will see the link in the description section below. So see you in the next tutorial.